Dear friends, in some of the earlier videos we have seen how t value is calculated manually, especially how standard error of difference between means is calculated manually in different situations by using statistical formula. Now, in this video we will see how t test is applied or t value is calculated with the help of Excel when two uncorrelated means are given. To understand that, we have taken one example. Here one example is given. Here the scores of male and female secondary school teachers of Ahmedabad are given in mental health test. Sample of male and sample of female are taken from two different populations. So, the means that we will calculate will be uncorrelated means, and to check the difference between the means of these two, the null hypothesis is formulated as shown on the screen. Null hypothesis: there is no significant difference between mean mental health scores of male and female secondary school teachers of Ahmedabad in mental health test. To find the t value or t test, to apply the t test, entire data is transferred in Excel sheet as shown on the screen. Here in Excel sheet, the data of male teachers are entered in column A and data of female are entered in column B, and the data range of male teachers is from A2 to A22, and the same of the female teachers is from B2 to B19. But to make our calculation easy, we will take data range of female also from B2 to B22. Now, we will count n number of observations of male teachers. For that, we will write this function equal sign count COUNT, count and data range A2 to A22, bracket over and enter key. 21 male teachers are there. Now, we will count n of female teachers. For that, the same function equal sign COUNT count and data range B2 to B22, bracket over and enter key. B2 to B22. Here B was not written, B2 to B22. So, this is n of female teachers 18. Now, we will find mean average of male teachers. For that, the function starts with equal sign, then we will write average and in bracket data range A2 to A22 and bracket over, then enter key. This is mean of the scores of male teachers. In the same way, mean of the scores of female teachers will be found. For that, function will start with equal sign and then average and in bracket data range B2 to B22, enter key, and we have got the mean of female teachers. Now, standard deviation of male teachers equals to STDEV. This is function of standard deviation, equal sign STDEV and then data range A2 to A22, bracket over and enter key. Now, standard deviation of the scores of female teachers, the function will start with equal sign and then we will write STDEV and in bracket B2 to B22, bracket over and enter key. These two are standard deviations of male and female teachers respectively. Now, for mean difference, we have to remember the cell address in which the mean of male teachers and mean of female teachers are calculated. The mean of male teachers is calculated in F2 and mean of female teachers is calculated in F3. That we have to remember to find mean difference. and it will start with equal sign, then we will write ABS. ABS stands for absolute. It gives the positive difference between two means. After writing ABS and starting bracket, we will write F2, that is cell address of mean of male teachers, minus F3, that is cell address of mean of female teachers, and bracket over enter key. Now we will find DF, degree of freedom. When two uncorrelated means are given, then DF equals to N1 plus N2 minus 2. N1 we have calculated in E2 and N2 we have calculated in E3. So, here we will write equal sign. N1 is written in E2, so we will write here E2 minus N2. N2 is calculated in E3. So, we will write here E3 plus E3, not minus, plus E3 minus 2. So, this is DF 37. Now, we will find probability, P probability. Probability shows at which probability level the difference between means is significant. To find probability, we will start our function with equal sign, then we will write t test, then we start bracket, and in bracket range of first data, that is of male teachers, will be written here A2 to A22. Then we have to put comma. After comma, we have to write range of second data set, that is of female. It is from B2 to B22. Then we have to put comma, and after putting comma, we have to write two tail test is to be done or one tail test is to be done. Here null hypothesis is there, so we will write here 2. 2 stands for two tail test and 1 stands for one tail test. Here, according to your hypothesis, you have to write our two tail test is there, so we have written here 2 tail 2. Then we put comma, and after comma we have to write 1, 2 or 3. 3 for two uncorrelated means and unequal variance. Our uncorrelated means are there, so we will write here 3. What is the use of 1 and 2, that we will see in coming videos. After writing this, we will press enter key, see again equal sign, then t test, then in bracket first data range, then comma, then second data range, then comma, then 2 for two tail test and 3 for uncorrelated means unequal variance. Now, we press enter key. So, probability value is 0.013, means our difference between two means is significant at 0.013 level. Now, we will find t value. To find t value, the function is there, it starts with equal sign, and then we have to write t I n v, t inverse, I n v means inverse. Then in bracket we have to write probability value, but probability value we have already calculated in I2. So, we will write here I2, then we will put comma, and after comma we have to write degree of freedom DF. DF we have calculated 37. So, we will write 37 and then bracket over again. To find t value on the basis of probability value, the function is equal t inverse in bracket probability value we have calculated in I2. So, we have written here I2, then comma, then degree of freedom, that is 37. We have written here, and now we press enter key, this will be t value. Now, how the interpretation on the basis of this p or t will be done, that we will see. For that, we take entire data, entire result that we have found, Here the results that we have found, statistical results, measures that we have calculated, how it will be interpreted, how the hypothesis will be checked. First of all, we see how on the basis of probability P 0.013 how the hypothesis will be checked. For that, simple three rules are there. If 0.01 is less than P is less than 0.05, hypothesis is rejected at 0.05 level of significance. See, what does it say? If the probability value is between 0.01 and 0.05, then hypothesis is rejected at 0.05 level of significance. Now, second is, if P is less than 0.01, then hypothesis is rejected at 0.01 level of significance. Friends, the hypothesis, if it is rejected at 0.01 level, then it will be rejected at 0.05 level also. Now, third, if P is greater than 0.05, if the probability value that we have calculated is greater than 0.05, then hypothesis is not rejected. In our case, the probability value is between 0.01 and 0.05. So, it is greater than 0.01 and smaller than 0.05. So, hypothesis will be rejected at 0.05 level, and it is shown in the column of significance, significance level 0.05 level. Now, we will see how hypothesis is checked on the basis of t value. T value we have already calculated 2.59995, we can say it is 2.6, and if t value is there, then we have to find df, that we have already found, it is 37. If t value and df are there, then we have to refer t table, and in t table, in the column of df we have to locate our df is 37. Here t table is divided in 3 parts. In first part, under df 37 is not there. In second part also under df 37 is not there. In third part under df 35 and 40 are there, but 37 is not there. In such case, we have to see the nearest value of df, that is nearest to our calculated value. Our calculated df is 37 and nearest is 35. So, we have to see in the line of 35, in the line of 35 under 0.05, 0.05 is the probability level, under 0.05 and under 0.01. We have to see these two table values. These two values are required table value for significance of difference between means at 0.05 level and 0.01 level respectively. At 0.05 level, required value is 2.03, and at 0.01 level, required value is 2.72. That we have to remember. Now, we have to compare our t value with these two values. See, t table value that we have seen at 0.05 level, it is 2.03, at 0.01 level it is 2.72, and our t calculated is greater than t table value. If t calculated is greater than t table value, then hypothesis will be rejected at that level. Here our t calculated is greater than 2.03, that is at 0.05 level. So, our hypothesis is rejected at 0.05 level, but it is not rejected at 0.01 level, because the required value for significance of difference at 0.01 level according to the t table is 2.72, but ours is, our calculated value is 2.59995, that is smaller than 2.72. So, our hypothesis is rejected at 0.05 level. Friends, here we have seen how t value is calculated with the help of Excel, or the t test is applied when two uncorrelated means are given. Now, in some of the next videos, we will see how Excel can be used to find t value for two correlated means. Till then, goodbye. Thank you.